There's a question that really needs to be answered, that has been around for a very long time and is going to trouble some people for a while. My name is Michael the Mechanical, and this is my video on engineering versus mechanics. So as a mechanic, I'd come along, I'd pull something apart, I'd replace a component or make repairs. Can you consider it being called repairs? Of course you can. There's so many things that can go wrong with a car and it requires someone to repair it. But how do they repair things? As a mechanic, we can fix an engine, we can fix a head, but what's the most simplest fix we can do on an engine or a head? The most simplest fix would be a nut, a bolt, a washer, something that's broken off like a stud. And how simple are these things to replace? Well, to be honest, they can be a pain to get out depending on their steel type. But they're as simple as a thread, a pitch, a head of some sort, a washer, and depending on if they've broken on in the hole or not, it will depend on how hard is it going to be to get out. As a mechanic, the most common kind of repairs I'd do if I were a mechanic would be to take off a head, replace the head gasket, put the head back onto torque settings and make sure that the car is going to run again. But I'd also be checking oil, I'd be checking coolant, I'd be checking everything with the car including temperature. I'd even be checking sometimes the electrical system should that break. So in retrospect, which one is more superior to the other? That is the question that I have for you today. But there's also an answer. As a mechanic, I have the skills to pull something apart and put it back together. I have the ability to source out new parts and get them for this particular vehicle. But here is the iffy question. What if they don't make spare parts for these anymore? What if they stop making head gaskets? There's no production whatsoever. This is the interesting question that a mechanic could be faced with replacing components on an engine. For me, I have a 4056T in my car. I destroyed my engine a little bit, but thankfully the engineers at Mitsubishi did a hell of a job when they designed the engine. Or should I say Hyundai? I get mixed up between the two on who actually designed it and who actually built it. I was told Mitsubishi designed it, I was told Hyundai built the engines. That is an interesting question that I'd like a clear answer from Mitsubishi or Hyundai. So what's the clear defining difference between a mechanic and an engineer? If a mechanic can't source a part, who can he go to get a new one or have one remanufactured? The engineer is the backbone behind the production engineering industry. He is the one that develops the nut, the bolt, the exhaust pipe, the head, the engine block, the piston, the con rods, the crank, the camshaft, the rocker arms. He's the one that can reproduce any part on a car and even build his own engine. But why don't engineers all build their own cars? The simplest answer to that question on why no one engineer built their own car, or not many of them have, is because it takes a hell of a lot of work to build one. For me alone to build this engine here from scratch, from just the raw materials, will probably take me a couple of years. Because if I don't have any calculations in mind for this engine, then I don't know what kind of power I want to produce, what kind of stress I'm going to have to put on material, what is the combustion chamber's dimensions going to be, and valve clearances. There's all these variable factors that go into it, and even my mind struggles as I'm not an engineer nor a mechanic. Though I have engineering experience and mechanic experience, I do know the superior trade is the engineer. Now, I don't want to boast or anything because the mechanic is superior at repairing and replacing parts on a vehicle. But there is a catch to how far a mechanic can go and an engineer. Should engineers stop making cars entirely? Should there be no cars on the road whatsoever and no one needs a mechanic at all? The mechanic is practically worthless. But in the case that the engineer is no longer needed, where there's too many cars on the road and there's not enough jobs, no need to hire an engineer to design more engines, design more car bodies, then they're practically redundant from a trade. So quite a few years ago, when I was still learning and I was building my very first engine, which is currently a running unit, there's no fuel in the tank and we're not going to start it. Sorry guys, but it does run. I decided that there was 2 bolts I didn't recognise, and I was growing my talent, and I took out all the bolts that I could recognise, which was count of 4, and then I was wondering why I couldn't get the head off. Now, this is where the engineering comes into this. I, as a rookie mechanic, a rookie engineer, someone that didn't know how to use a welder, someone who didn't understand why the head wouldn't come off, decided to get a screwdriver, pry the front and the back, and decided to crack the head in half. When I realised my mistake, well, guess who fixed it? The engineers. The evidence is all under this cover, and here is another head to show you where it would have cracked in between. I apologise for the poor lighting. I can see the lighting is bad. Let me fix that in 1 second. That was 1 second. Look how quick that was. And now you can see a little bit better where it would have cracked, which was in this gap. That is basically where my head cracked. Now here's the problem. As a mechanic, please be clear as possible. How many of you can actually fix a head? How many of you can weld a head? How many of you can get an angle grinder and grind the head, which unfortunately never happened? This is an almost perfect surface on the head. How many of you can make a perfect surface like that? Well, unfortunately, there's not many people who can, unless they have the high-tech machinery that takes up both space and time to use and time to set up. There's also variable factors, which also includes how tight you can put the bolts on such material. You put it too tight, you make it warp and flex while you're machining. You do it too loose, the material goes flying and probably harms someone in the course of its flying. What can a mechanic do that an engineer can't? He's more efficient, he's faster, he knows an engine inside out. What does an engineer do? He makes the stuff that you need to rebuild this motor, this head, this motor. These components, which you can't source anymore, he comes along and remanufactures them. But there's only so much that some engineers can do. There are mechanical engineers, there are fitter and turners, there are CNC operators, there are metal fabricators. There's all sorts of engineers, including the ones that are precision engineers. My dad's a fitter and turner and a precision engineer. Now, here's the great thing about what my dad's done for me. Recently, he basically precision engineered 2 new bushers for an injector pump. You may know about the pump that I'm working on now. It's still in progress, it's still not finished, even though you may have seen it get finished in one of my recent videos before or after now. And the reason it's not finished is because I had made a small mistake. I got a component in the wrong way around because I'm developing my skills. I have schematics. Guess who makes those schematics? The engineers make those schematics. So you get an idea of what a schematic looks like. This is a schematic. It shows all the components, the orders they go in, which one's going first, which one's going last, how they assemble, and where they have to be once they're assembled. The great thing about this is I've never seen a mechanic show me something like this that he's made himself. The only thing I know is, as a engineering Cert 2 student, as I have been before, I managed to make something like that. In high school, I managed to make a drawing like this. I built a 9-cylinder motor in an AutoCAD program for school. Guess what my mark was? I got an A. Why? I didn't even know how to use the program. I was that far behind. The students that were in my class, they already had a year on top of me for engineering at school. It was actually called metalwork. It wasn't called engineering. but we all made something. But I made something that was better because it was animated. Now, why do I say it was better? Because I felt I need to go the distance to say I can make something. I don't know how I'm going to make these things in a short amount of time because I don't understand the programs well enough to do that, but I think I can make this with a bit of help. So to explain where I am in engineering right now, I still only have a Cert 2. I only have a Cert 1 in auto mechanics, and yet I can still build an engine, I can still fix things, but I can still break things at the same time because of inexperience. So what am I doing at the moment doing engineering? Because I'm not an engineer, but I am doing engineering at the moment. Today, I made a drawing up. I had a bit of assistance because I didn't know how to use the program. It was very complicated because it was a very old school program, and because of that I struggled quite a bit, so I had some assistance using that from someone more experienced. We had to make the decision on accuracy, which was another factor in deciding if this item is going to fit, if it's going to work, if it's going to be the correct fixture. Then we had to test cut. Now here's the problem. The test cuts were not successful, they didn't work the way they should have, and there was a missing wall to make it strong, so it cut the wall straight out. The problem was we had that problem happen twice to us. The third time we were lucky and we didn't have to clean the surface, but the first time we had to because of all this material built up around it on the wrong side, but also because it caused a few bits of chaos. So with this component that we're making, it has now been successful, and the first part of making this item has been successful. The second part is turning it off correctly. This means that someone has to put this item in a chuck and cut it off as carefully as they can so they don't damage the component. They also have to try and be accurate as possible with their cuts to make sure there's enough material there. At the same time, there is a step if it needs to step, which in this case, luckily we don't have to be that accurate. We don't need the step. It can be just a flat piece of material. With this part, it then has to go into heat treating, meaning it needs to go through a 4-stage heat treatment. When they do this, they first got to make it a strawy colour, then they have to heat it up and turn it yellowish, then they have to turn it blue, and then they have to, I don't even know from memory because it's just 4 stages, and this is how they identify how much heat is in the material and when they stop and when they start and when they cool it, when they let it cool by air, when they cool it with oil. Yeah, this is complicated stuff to me because it's new territory. If a mechanic was to walk up and do some heat treating, does he know what the bloody hell he's doing? Unfortunately, I don't, and I'm only a Cert 1, but I'm also a Cert 2 engineer. The chance that the mechanic knows about heat treating and how to heat treat something, very unlikely. But he would understand that the head's hardness is important in some cases, actually in all cases. If it's too soft, it's likely to warp, it's likely to crack, lots of things will go wrong. So if it's soft, he'll get a replacement head instead of using that soft head right there on the bench. No, this head is not soft, but it's an explanation of you wouldn't put that on the car if it was soft because of all these extra problems that are going to come along down the road. As a mechanic, you might have some welding skills that you might be able to weld up a new exhaust. Now, this exhaust here was cut because it was rusty in this section, and so we decided, you know, let's get a tube, let's weld it on here, and make it go out further than having it close up over here, because hey, a longer tube and a stronger tube means we can pick it up here and it'll take a lot more load. This is also heavier, so it will be easier to carry this around because otherwise it's very hard. There's not much to carry it by unless I use a rope. I'm going to share with you a little thing that engineers do when they're actually fixing something. Say for example, see this crank here? And see how that has a nice, smooth, polished surface here? Well, the secret to to getting that polished surface is to use, first of all, if it's damaged, a high grit paper, and have this spinning on this point. So it will be spinning on that exact point, and it will be off-centered, so it goes on the one point in the chuck. So this here is spinning as true as possible, meaning I have a mic on here and it'll always spin on that point. It'll always be touching that point and will be zeroed. So that, while this is spinning 180 degrees, like so, it'll do that and it'll just stay in one point. That's the best example I can give, unfortunately, but that's how it basically works. The center is here, and this is the point we want to spin on, but we can't. So we have this offset over here, and we grab this on a 4-jaw by pushing the jaws that way until we grab it, and then it will just spin around like so. And that is how it will spin to get this right. They use an emery paper high grit on this if it's damaged, and they'll grit that as much as possible. Then what they'll do when that's a nice clean and smooth surface, well actually it's going to be rough, they then use a lighter grit to get the surface down. Then they'll use another grit to get the surface down even more, and then they use something like 2,000, 3,000, 6,000 grit to make that a perfectly polished surface that you can feel it and there's no imperfections, and it's like a bearing. That is how that surface there works. So, to explain the rest of this stuff, most of this other stuff will be a little bit of emery here and there, but that's how it basically works. So, if you're a person that does body repairs and does bog repairs and all sorts of things, there are multiple grits you'll get in which you'll use to repair a car. So, these grits here are 80, 120, 320 and 800. Now you can get higher grits than these, and they do a lot more perfections job, and you can see it says basically it's particles. That's an 800 grit, and it's a lot smoother than the coarser grit, which is 80. So for example, this is the order I'd use it in. Here's my high grits. I'm going to put these down on a clean surface. I'm going to grab my shaft, and here it is rusty as a bugger. So to make this nice and shiny again, make it look nice and silver, I'll just get this, and if I had this in a lathe, which I could do if I really wanted, I'll actually show that to you guys. This here is called a lathe. We use this to machine components, we use this to clean components, and we use this for many different things. This one still has its uses. It has some repairs that need to be done. Other than that, this is called the Bantam Colchester Bantam. The problem with this one is it needs a hell of a lot of work to get it to work very well. Not to mention, you have to clean it every time you change the tools, according to engineers who actually operate these machines on a daily basis. One of which is my father. Now we're going to clean up a little bit, make sure that everything is clean and ready for operation. Then we'll get back into using the camera and recording what we can do with our components. So we've cleaned up a little bit, not perfection, but we have our shafts. We're going to put it in here. The engineer who knows what they're talking about told me I shouldn't really do it this way. And he said, if you want to do it, wait till tomorrow. But unfortunately, I can't really wait till tomorrow because I'm making this video now. Okay, so this is what we're going to do. We're going to tighten that up. It's nice and tight. And this operates by a simple level that's right here below the camera. So if I dismount the camera, we can look at the operation tools of a machine. So this here is our lever. Now, engineers that are fitter and turners by trade, but are considered engineers these days, that's the catch. When you call someone an engineer, some of them are fitter and turners, but now called engineers, and the reason they're called lazy is because some engineers just sit a chair all day at a desk and come up with ideas. So to operate this, here's the lever, we pull it up, and it makes the chuck spin that way. We push it down, it turns it off, push it down again, and it puts it in reverse. Now, the safety feature about this lathe is it has this little foot pedal here. This one needs some work, so I'll show you why it needs work. This is the worst lathe in the world. And that's why it's the worst lathe in the world. Because this bar needs to be fixed up to shut her down properly, but also because this thing is got too much play in it that we can't really do nothing with the tool post. Tool post can house 4 tools, up to 4 tools. This one here is a cut-off tool. The cut-off tool is out because it broke. This one here is a little cutter. I don't even know what that's called, but it's carbide burr. And it's currently housing 2 because it can only house 2 at this point in time, since one's big, one's small, and these spacer plates are way oversized for this tool post. So what we're going to do is we're going to push this tool post out of the way and hope the key doesn't fall out. And the key did fall out. That is why this machine is a baby. This is why it is a yucky machine. This is why I dislike this machine, because it breaks too often. And you've got to be careful. There's this bar here that spins, this bar spins. And what we're going to do is going to turn it off, and we're going to clean this with emery paper.
That's even got jaw marks in it. That's been so hammered. It's not even funny.
206 RPM.
Oh my god. Change the gear.
Okay,
that one's got to go to the right, I believe.
Okay, what speed do you want?
The max.
Okay, we want the max 800. That goes that way.
Yeah.
And that is on second highest speed. That is this.
Did you switch that on the high? That's on high.
That is on high. Do you want faster?
How come it's not fast?
Because this goes to this, you get your fastest speed.
Come on. I want to see it.
Yeah, that's its fastest.
Oh, that's more like it. Yeah. And if you go down here, hold your hand here, it's going to pull you in and rip your fingers off. If you hold like this, it's cradle. This will rip your fingers off. If you close that valve up, stay back here. Whoop! And the reason you do that is because if you don't cradle the paper is going to polish off the keyway only, because that's where there's no material when you're pulling on the paper. Okay?
Yep. Is that nice and shiny enough?
It's shiny. But, there's a but. This shaft really needs building up and remachining because of all the vice marks in it.
So the engineer that I have that's been helping me decided he didn't want me to touch this and decided to give you a little bit of helpful advice, as well as showing you how to do this another way, which is actually in his eyes a proper way, because he didn't want me to make a mistake. In the end, he decided he wanted to do it and do it properly, but he also mentioned why basically I decided to use this as my sacrificial piece and do a practice on this. And after you have a good look, it's not perfect, but this is the end in which he basically did work to it. And you can see the difference in colour with the keyway, and you can see all the imperfections on the surface. Now, if you heard what he said about building it up, then yes, that is true. He needs to build it up and machine it. Now, excuse me while I get ready. There is a mosquito flying around, bugging the crap out of me up in here, having a good talk with him, and you know, it's been fun. Because it's fun to talk with him. He's very nice, he's very cool. But as you can see, he can make something look good again using emery paper. Now, if you remember what this looks like before from the previous video, and you see the video where he done the machining on this, you can see how valuable these machines can be depending on the scenario. Now, that's only a small margin of what he can actually do with that machine. He can do so much more. He can put a thread on here. If he really wanted to, he could put a keyway on here. He can put a taper on it. He can even put a screw cut on there, or screw cut in. He can bore. He can do so much that makes this all possible. If he wants to, he can offset this and make a whole crankshaft if he really wanted to. But does he really want to do it? Not really. It's a lot of work to make a crank, and there's no point unless you're going into major production or it's just something unique. You want to make a one-off build. You have a block, you want to make the crank for the block. Like I said, there's mosquitoes trying to bite me, and this is a pain in the butt. I don't have no air guard. Apparently that attracts them too, which is bad. Well, anyway guys, from what I know, I love engineering, I love mechanics. It's all fun, but the end of the line, an engineer is more useful than the mechanic in making things. But the mechanic is useful to a casual person on an everyday basis, because a mechanic will fix your car, whereas the engineer will make the parts for said car for the mechanic to fix and send back to you. So in the end, the mechanic is the first party and the engineer is the third party. So if anything needs to be made and it has to be specially ordered or whatever, it goes to the engineer. Now, by trade, the person who is the engineer, he was a fitter and turner by trade, but the government decided to stop calling him a fitter and turner and decided to call him an engineer. So you guys really need to know this, because if you call someone an engineer stupid now, it refers to him as well, and he's not that stupid, since he can make your crankshaft, he can make your harmonic balance, your pulley, your flywheel, he can make anything. So all in all, this is the kind of stuff that you can do. Now, I know I haven't shown much of what they can do, but right now I'm limited to what I can do with this machine, and this machine here doesn't have many cutters. We don't have many cutters here, but it does cost a lot to do machining. So I should note to you, one cutter costs about $20, that's just for a tip, and the tool holders, they cost something like $200+ for a set, depending on the sizes you go for. Anyway guys, I want to thank you all for watching. If you liked the video, let me have a thumbs up in the comments. Let me know what you think I should do for another video. Let me know what you think of engineering and mechanics and automotive, and what your opinion is of both trades. Whether you think a mechanic is better than an engineer, or an engineer is better than a mechanic. You all are entitled to your own opinion. It's just my opinion is the engineer is much more superior trade, whereas the mechanic is a much more helpful to people sort of person. They can do more than the engineers can do, because the engineers don't have much work to do anymore. Anyway, catch you later. This is Michael Mechanical signing out.